Well, hello Internet, and welcome to my Go programming tutorial. You may ask yourself, why is Derek doing a tutorial about Go? Well, basically Go brings together the best of both worlds in regards to striking a balance between both dynamic as well as statically compiled languages. As you're going to see, the code is both easy to read as well as the specification for Go is quite short, even though it includes ridiculous things like a built-in web server, and yes indeed I will cover that. And I basically decided to cover Go because it allows you to set up an app quite easy, and in this tutorial I'm going to cover all the basic syntax for the entire language. So I'm basically going to leave installing Go all up to you. It's quite easy. Just go to golang.org/dl and find whatever operating system you're using, click on it, and install it. And for the most part, you're just going to be using a basic text editor as well as the terminal, or if you're on Windows, you're going to be using the command line. And here we are. I have a basic text editor over here, and here I have my terminal or my command line. I'm going to be typing in code over here and executing it over there. Now basically every Go program is going to start with a package declaration, and you just type in package and main. And this is basically going to provide us with a way for us to reuse our code. And in this situation, I have main here because this is going to be an executable program. We're then going to be able to import all types of things. Like here, I'm going to import a format package, which is going to allow me to provide formatting for both input and output. You can have comments by just typing in 2 forward slashes, just like that. Or you can have multi-line comments just by typing in a forward slash and a star, and then a whole bunch of things and a star and a closing slash. And I'm going to move quite quickly through this, so if you want to jump to any specific part, just look in the description. We're going to come in here and define a function. This is going to be the main function, which is going to be called for execution whenever the application is executed. And a function is going to open up with a opening curly bracket and close with a closing curly bracket. We'll get more into actually creating your own functions here in a little bit. We're going to be able to use a function called printline by referencing the format package, and this is going to allow us to output information onto our screen. And this is basically all you would need for a basic hello world program inside of Go. You can see over here we can execute a Go file, and the name of it is herewego.go. The extension is go, and you would just type in go run and whatever the name of your Go program is, and you can see hello world prints out like that. Another thing's kind of interesting, if you have the terminal over here, you can just type in go doc and then whatever the package name is, and then whatever function you're interested in. It's going to provide you all sorts of information in regards to what that function does and how it operates. Now variables inside of Go are statically typed, which just basically means that the type can't change once it's defined, and your variable names are going to start with a letter, just any letter, and they're going to be able to contain numbers as well as underscores. One of the variable types you're going to have are integers, and you can see right here all of the different integer types. There's unsigned for 8, 16, 32-bit, as well as 64, and then there's regular integers for 8, 16, 32, and 64-bit as well. But for the most part, we're just going to use basic ints, and you can see how big these guys actually get. They get quite large. Now, there's a couple different ways to define a variable inside of Go, but I'm going to start off with this one and cover the other ones as we go. Just type in var age, and then you're going to type in whatever your data type is. You can type int 64 or just int. Like I said, normally you're going to use int, and then you're going to assign a value to that variable type. Then you have floats, which are going to be numbers with decimal places, and they are either going to be float 32 or float 64. For the most part, we're going to use float 64, however. And you define those in much the same way. You're going to come in here, give it a name, so say favorite number, followed by whatever the data type is equal to 1.6180339. As you may have noticed, you do not need a semicolon at the end of all your statements, but you could put one in there. It's not going to cause an error. Another way we could come in here and define variable types is just by putting colon equal to and then throwing something in there, and Go is going to be smart enough to automatically create an integer for that. And of course we can come in here and print these guys out with random num, but I'm going to hold off on that for a second, because if I tried to do that and I went and created variables that I didn't need, that is going to throw an error. One thing that's important to know here is while Go will automatically go and create this random number and assign it an integer, we're not going to be able to come in there thereafter and go random number and type in something like a string, which is going to just be a series of characters between double quotes. So once it's an integer, it must remain an integer. This right here would cause an error. We would then be able to use these variables inside of printline. So let's just go printline and then say age. and this is automatically going to put a space in here, but if I actually go in and put a space, it's actually going to put in multiple spaces. But let's just do this just to see what happens. And there you can see it executed, and also it put in multiple different spaces here. So let's just get rid of this, and now you're going to see it automatically threw a space in there. Another thing that's important to know is while integers are going to provide you an exact result whenever you're performing arithmetic, floats often will not, and I'll just demonstrate that right here. And this is true of every programming language. This isn't just a Go thing. So number 99 is equal to 0.999, and we can also perform arithmetic directly inside of the print line. It's going to output that on the screen. So let's just say we go number 1 minus num99, and if we execute that, you can see how it comes out kind of wacky. That's just one thing to think about, that your floats are not always going to be 100% accurate. And in regards to the type of arithmetic operations you'll be able to use, you'll be able to use plus and minus and multiplication and division and modulus, which is going to return the remainder of a division. And just to show exactly what that's going to look like, right here you can see all the different arithmetic operations. I'm going to save that and execute, and here you can see the actual arithmetic operations and their final answers. Now I'm basically going to bounce around a little bit in the language. Let's say you want to create a constant. You would just start off with const. You're going to have to define the data type for it, however, and then we can just come in here and type in 314, 159, 265, or whatever. And then once that value is set, it's not going to be able to change. You could also declare multiple different variables. There's a whole bunch of different ways to create variables inside of Go. So we could go variable A is equal to 2, and variable B is equal to 3, and then close that off with the closing little bracket there, parentheses. Now strings are going to be either a series of characters between either double quotes or backslash quotes like that, but for the most part you're going to use double quotes. They're going to be defined in exactly the same name, so I could just come in here and do a string is equal to and type my name inside of here, and there you go. You could then get the string length. Let's say that I want to print it out on the screen. We just type in len. Of course, you could assign this to a variable or do whatever you want with it, and type in my name, and you're going to see that that's going to show up. Let's just comment this out right now so it doesn't throw an error, and there you can see 11 came back for the length of the total string. Also going to be able to come in here and combine strings with the concatenation. Make sure this is an uppercase print line. Be able to combine strings with the concatenation operator or the plus sign, whatever you want to call it. You are, however, going to have to put a space in this situation. So let's say robot, and there you can see it printed out. Another thing that's important is if you wanted to come in here and use your double quotes, you're going to, of course, be able to use backslash symbols like new lines. So let's say I go I like, and then throw a bunch of new lines in there. I could then create another one and then just type in new lines under this. Let's comment this out, and there you can see all the new lines that show up inside of the output. Another data type that we have available for us are Booleans. So let's say we go is over 40, and they are defined with BOOL, and they're going to have either the value of true or false. Something else that's good is while we have print line, we also have something else called Printf, which is going to provide us with different ways to format our output. And I'll just run through these right now. No need to come in here and try to memorize all this stuff, but just in case you wanted to know how to do it, you wanted to know how to print out a float, this is how you do it. You could throw in a new line there. It's very important to use new lines with Printf because it doesn't skip to the next line after it outputs on the screen. And we could put pi inside of there. And let's uncomment this. And another thing we could do with floats is we could define the precision of the decimal places. So we put 0.3 in there, and it's only going to output the first 3 decimal places, as you can see right there. But you don't need that there if you don't want that precision. Let's say you wanted to get the data type or output that on the screen. Just put an uppercase T inside of here, and then you can throw anything in there, and it's automatically going to return whatever the data type is. And you can see right here, float64 comes back for that data type, which is exactly the same as what we have defined up here. If we want to print Booleans, change this to a lowercase t, and of course throw a Boolean in there, is over 40, and uncomment this, and you can see true shows up there. Going to use % and d followed by anytime you want to have an integer show up inside of here. Just keep this simple and just put 100 in there. And then there's all kinds of other odd things, like if you wanted to get the binary representation of 100, you wanted to get the character that has the character code of 44. If you wanted to print hex codes, use X, and we can type something like 17 in there. And then if you wanted to get scientific notation, just put a lowercase e, and let's throw pi in here just for the heck of it. And execute, and you can see all those different things come out. There's 100 for the decimal. You can see here is 100 in binary. You can see that the comma is a representation of 44 in regards to characters. 11 is the hex code, and here is scientific notation for pi. There are 3 logical operators inside of Go. So let's go print line, and your logical operators are going to get Booleans, and the first one is and if you put false inside of here, this is going to return false. And let's just actually show that here on the screen. So if you have true and false, this is of course going to return false, because both of those values need to be true. And these are also used very commonly whenever you're using conditional operators if you want to check multiple conditions, and I'll get to that in a second. Or is going to provide us with a way to provide a true if either one of these is true, which this is of course, so that's going to return true. And then the last logical operator is the not symbol, which is going to return exactly the opposite of whatever you put in front of it. And if we come down here and throw the not in there and save that, you're going to see exactly how they output there on the screen. Of course, let's go into for loops, which is going to provide us an option to be able to do something multiple times, and we'll create an iterator here, give it the value of 1, and we can create for loops in a couple different ways. Let's say we want this to loop as long as I is less than or equal to 10, which is going to print out 1 through 10 here on our screen, and we could just print I out on the screen. Then you could have I++, which is going to be shorthand notation for I is equal to I plus 1, but that of course saves a lot of time, so these two things are exactly equal. And of course you're also going to be able to come in here and use shorthand notations for negative negative, which is going to decrement the value. And you can see they printed 1 through 10 there out on the screen. And of course always make sure the P in print line is uppercase, otherwise that will not work, because those are completely different functions, being that one is a function and the other one is not a function. Now we looked at logical operators. There's also a bunch of relational operators you're going to be able to use. Going to be equal sign and or equal to, and then you're going to have not equal to, less than, greater than, less than or equal to, and greater than and equal to. Pretty much exactly the same as you've seen in pretty much any other programming language. Another way we're going to be able to define for a loop is actually to define what we're going to be iterating through here right on one line. And we just create that, and here we need semicolons. And let's say we want to do it as long as j is less than 5, and then we're going to increment the value for j all in one area. And this time we were going to be able to come in here and actually print out the value for j all in this one little box. Save that, execute, and there you can see it printed out 0 through 4. And the reason why it didn't print out 5 is we said we want to loop through it as long as j is less than 5, and that's why whenever it hit the value of 5, it skipped over this and did not print 5 out on the screen. Now, since we have for loops, of course we're also going to have if statements, and let's go and create something called your age, and let's give this a value of 18. We're then going to be able to perform different actions depending upon different conditions. So if your age is greater than or equal to 16, we're going to say, alright, we want to come in here and print out on the screen, you can drive. Else, and we're going to just type in else, if that condition is not true, then we're going to come in and we're going to say something else. So let's say print line, you can't drive. And if we execute that, you can see you can drive shows up there. One thing that's important is once a condition is met, this code here is going to be executed, and nothing else, no matter even if it is true, is even going to be seen inside of if then else statements. Another thing, of course, we're going to be able to do is go and create multiple different conditions. So we can say else if your age is greater than or equal to 18, you can vote will be an option here. And then we can say else as a default option, something like you can have fun. You're going to see that when it executes, you can drive shows up, even though this condition here is indeed true. Another way we can check multiple different values is the switch statement. So we could have your age here, and you're going to use this anytime you have a limited number of potential values for your age. So we could say case, if the value of your age is 16, we could have go drive in here. Case, the value is 18, we could put go vote in here, and then otherwise if nothing else matches we could go and put default and have something like go have fun. And of course come in here and put your age and equal to, we can put 5 in there. And there you can see go have fun shows up. Now let's go and take a look at arrays. And basically an array is going to hold a fixed number of values of the same data type for you. So let's say we have an array that is called favnums2. We could come in here and say that for the most part, we could come in here and say we only plan on having 5 total favorite numbers, and we expect them to all be floats. We could then come in and define each and every one of those just by putting in the variable type name and an index. The index is going to start off at 0 and go all the way up to 4 to take up all 5 spaces. This is going to fill the entire array. We're going to to be able to come in here and access those by passing in the index that we want to show. So let's say we want the third index to print out here on the screen. There you can see pi printed out. And another way we could initialize an array is go fav nums 3 and then type in the total number that we want inside of here, and then float 64, and then inside of curly brackets put all the different values we want to store inside of there. Now we're going to be able to really easily iterate through the entire array. We'll just say 4, and then we'll put I value colon equals 2, and range is going to allow us to get every single value out of our array. So favorite nums 3. Now we're going to be able to print out both the value as well as the index that's associated with that value. And there you can say it printed out all those different guys, 1 being the value and 0 being the index, and onwards and upwards. If you did not want these indexes to show up here, or you have no need for them, you could come in here and just put an underscore right there, and that's going to completely disregard that. So we can just come in here, get rid of that, and execute, and you can see everything shows up right there. Now a slice is like an array, but whenever you define them, you leave out the size. So let's go and create a slice. Let's call it number slice, and there it is. You're going to put in the brackets just like you do with an array. Let's just say this is an integer slice, and let's go and throw a couple values inside of there. Another thing that's interesting is we'll actually be able to make a slice by slicing from another slice. So let's go and define a new one called slice2, and let's say we want to take some values from numSlice, the first one we created. Here we're going to say that we want to start off at the third index, and we want to take everything up through the fifth index. We could then check to see what is in the 0 index for this slice. Same way we use arrays, right like that. And there you can see back 2 comes out there. And why is that? Well, the reason is this is the 0 index. This is the first, second, third. And to get 2 and 1 and to put them into slice number 2, what we're going to do is we're going to say that we want to get from the third up through the fifth, which is actually going to get the fourth and ignore the fifth. I know it's kind of weird, but whenever you put 5 in there, it basically means get 3 and 4 and ignore 5. As you're going to see, if I come in here and put 1 and 1 right there, that's going to show up. However, if I come in here and put 2, that is not going to show up. Say, bunch of errors. A little bit weird, but you'll get used to it. If you do not supply the first index like we did here with the 3, let's say for example, we get rid of this altogether and go numSlice and then type in colon and 2 like that. And then of course define the same thing outside here and execute, you're going to see that 5 and 4 show up. Basically what you did here by not putting a number before this colon is you're saying that you want to start from the first index, which is going to be the 0 index. So that would be exactly the same as if you typed in 0. Also, if you wanted to type in 2 and colon and put nothing here, that is going to be the same as if you said you wanted to get all the indexes. As you can see, if I come in here and type in 2 and colon and execute that, it's going to get 3, 2, and 1. You're also going to be able to create a slice that is not going to have a defined set of values whenever you start off. To do that, we go numSlice is equal to, and then make. Then you're going to define the type of slice you want, which is an integer array. Then if you want to provide a default value of 0 for the first 5, you would just type in 5. If you wanted to have a maximum size for the slice of 10, you would type in 10. Then you could copy over into slice number 3 the values in the first numSlice, and if we output those onto the screen, you're going to see that yes indeed those values were passed over. And I could cycle through and prove it, but you know, you get the point. And also, finally, we would also be able to come in here and go something like numSlice 3, and if you wanted to append some new values on there, remember we have room for 10 total values inside of this slice. Just call append the slice that you want to append values to, and then just keep listing values as long as you have space. So let's say I want 0 and -1 on there, and I want to print this out onto the screen. numSlice 3, and then let's say I want whatever is in the 6th index, and you're going to see -1 shows up because I put the -1 right there. Now let's take a look at maps. And a map is just a collection of key value pairs. You're going to have a key that's going to be associated with a value. So to create one, say we want to have a map that's going to have president names matched up with the age they were when they became president. You're going to type in make followed by map. Then you're going to define the data type for the key, which is going to be string in this situation. And then int is going to be the value for the values we're going to store inside of here. We're going to be able to come in here and go pres age and do something like Theodore Roosevelt. I think I'm spelling that right. That would be a very weird key, but what the heck. and I give it the value of 42. We're then going to be able to get the value for this just by passing in the key. So like that, and you can see 42 popped up there. You'd also be able to get the length for this, and of course you could store this length in a variable or do other things with it. I'm just doing this just so you can see the output immediately. And type in len to get the length, and there it is. And then after you create one of them, you're going to be able to create more. So let's go president's age again, and you could also put spaces inside of here. Just doing this just to show some weird things you can do. So F Kennedy, if we wanted to do that, 43, and then we could also see that the length of our map changed. And there you go. And we're also going to be able to come in here and delete items from our map by going delete, pres age, and then typing in whatever key we want to have deleted. So John F. Kennedy, and then length again to show that it's no longer there. And there it is, back to 1. And I could actually show you how to put maps inside of maps. In the description I'll put a link to the code, and inside of there I'll show you how to do that. Just something kind of weird you might want to know how to do, but a little bit more crazy than what this tutorial needs to cover. Now you're going to have functions other than the main function also. So let's say that we want to have a list of numbers, and it's going to be a float array. And let's go and put that closing bracket right there and define it just as something really simple, right like that. We're then going to be able to come down here and create another function, and I could call this add them up. And this is going to allow us for a way to reuse our code as well as provide some structure to our program. And to create this, you're going to type in func followed by whatever you want your function name to be. There's going to be a list of parameters that are going to be passed inside of here. In this situation, I'm going to be getting a float array, so I'm going to define that. And then after that, I'm going to return a float, so I'm going to put the return type down here. So here you're going to have your attributes, and here you're going to have your return type. Then you're going to have curly brackets, and then here we're going to define sum. And just so you know, any value that is assigned or created inside of here, or variable that is created inside of this function, is not going to be accessible outside of that function. Just give that a value of 0. Then we're going to cycle through 4. We're not going to care about the index value for this array, so we're just going to put an underscore like I talked about previously. Going to get the value. I'm going to type in range here so that we cycle through every single item in our numbers float array that was passed here. And then put our curly brackets, of course. And then I'm going to be able to go in here. Here's some more shorthand notation. If I wanted to add a value to sum and then save it back to sum, I would just type in plus equal to and val. And of course that's going to be the same as if we would say sum is equal to sum plus val. And we're also going to be able to come in here and put negative signs or multiplication or whatever anytime we want to perform an arithmetic operation on a value, and then save it back to itself. And then after I cycle through all those, I can come in here and return the value of sum. And then I could call that function from upside of main and print it out if I'd like to. I could just go sum like this, and then add them up. Passed in my float array, list of nums, or instead list nums, and change this to range. Sorry about that. And here you can see that the sum comes back as 15. Another thing that's really interesting about Go is we will actually be able to call a function that is going to return 2 values, which is really kind of neat. To do so, we could say num1 and num2 is equal to, and let's create a function called next to vals and pass in 5 inside of here. And whenever we get these back, we could print them out on our screen. So to return 2 values, we go function just like we did before, next to values. This is going to receive a integer that I'm going to call number. Put our curly brackets inside of here. And then if we're going to be returning 2 values, you're going to put a brace inside of here with int and int if you're going to be returning 2 integers, and it's going to assign those properly. And then we can just say return and number plus 1 and then a comma and then number plus 2. When that's executed, it's going to return 6 and 7. So that's how you return 2 values from a function. Kind of neat, because most programming languages don't allow you to do that. We're also going to be able to send an undefined number of values to a function, and this is referred to as a variadic function. So let's just go and print out the output from calling this function, and we'll say something like subtract them. And we could have all these different values subtract from each other and get a final result. How we're going to accept these multiple values is to create a function down here, and of course it's going to be called subtract them. And if I don't know how many values I'm going to be getting, I'm going to type in args followed by ... and then the data type I'll be receiving, and then follow that up with the data type I'll be returning. Then I'll be able to go in here and do something like final value is equal to 0. I'm going to cycle through all these values. I don't care about the index, so I'm going to just put an underscore type in value, and I'm going to type in range. Don't know why I'm spelling that wrong. And cycle through all the arguments that are going to be passed in there. Don't need to know how many. And then I could go final value, and then here I could subtract. Shorthand notation from subtract from itself and save back to itself, and then finally return the final value. And you can see there negative 15 comes back. We're also going to be able to come in here and create a function inside of a function. Here I'm just going to use function main. Let's go and get rid of this extra curly bracket here. And whenever we do that, remember I said if you go and create a variable inside of an outside function outside of main, you're not going to have access to any of the variables inside of main, nor are you going to have access to the different variables that are assigned outside of main. However, if we use what are called closures, they're going to be defined inside of main and have access to pretty much everything. To define a closure, we're going to say something like number 3 colons equal to, let's just give it the value of 3. Then we'll go double num and define our closure. And to do that, we'll just go function. It's going to return a value that it is an integer. And this is the function. And it's ultimately going to be saved inside of this guy right here. Then we can just go number 3, another shorthand notation, multiplication, times 2, and then save it back to the value of number 3. And then we can return number 3. See, I'm able to access this variable inside of here even though it is outside of my function. And then on top of that, say I wanted to double it multiple times, we could go double num, call that function, and then call it again. And once again, you don't need the semicolons, but they don't hurt. There you can see 6 and 12 pop back. Another thing that confuses a lot of people is something called recursion. This is whenever we call a function from inside of itself. And this is often demonstrated through the use of generating a factorial. So let's call or create a function called factorial. It's going to be receiving an integer. I'm going to call it num, and it's going to be returning an int. First, anytime you use recursion, you're going to need an out, which is basically what this is going to represent here. If number is equal to 0, well, in that situation, we're going to return a value of 1, which is going to end the function. Nothing more is going to occur. Otherwise, we're going to return num times factorial. We're going to be calling itself and passing in number minus 1. See, we're going to be calling the function from inside of itself. Now the way this is going to operate, well, let's jump up here first and let's call factorial, and let's pass in a value of 3 into it. Now what this in essence is going to do is 3 is going to come down inside of here. I'm going to put some notes right here just so you can see it. So we're passing 3 into the factorial. So factorial is going to get a value of 3 passed in the very first time. It isn't going to be equal to 0. So we're going to come down here, and in this situation, we're going to have 3 times, and we're going to pass into factorial once again, 2. This is going to be equal to 3 times 2. Same exact thing. That's going to give us, ultimately, a value of 6. This 2 is going to come from the fact that we're going to come here and pass in 2 times factorial, and this time we're going to pass in 1, which is going to be equivalent to 2 times 1, which is going to give us the value of 2. Well, this 2 right here is exactly the same as this 2 right there. And then finally, we're going to come in here and go factorial, and we're going to pass in 0, which is going to be equivalent to 1. So this 1 right here is the same as this 1 right here, and that is the reason why the factorial of 3 is equal to 6. Hopefully that made sense. Play around with this idea a little bit, and all of a sudden you'll get it. That's the way working with recursive functions actually works. You just have to stare at it a little bit, and eventually it just makes sense. Didn't want to skip that because that is often something that a lot of people skip in tutorials that I think is rather important. Now while I'm down inside of here, I might as well cover defer and how that works. Another thing's kind of interesting. Let's say we have one function called print1, and it is just going to print the value of 1 out on our screen. And then let's have another function called print2, and it's going to print out the value of 2. Now up inside of main, I'm going to come up here and I'm going to type in defer print2, and then I'm going to call print1. Now we want the 1 to print before the 2, and it will because of defer. You're going to see here a little bit later exactly how defer is really helpful. I just wanted to demonstrate what happens here. Basically what happens is defer is going to execute a function after the enclosing function finishes. So after main finishes, it's then going to print the 2 on the screen because defer is here before that function. Even though it comes first, it is not going to print it immediately. And defer is normally used to keep functions together in a logical way, but at the same time, it's going to allow you to execute one last function as a cleanup operation and know that it will actually be executed at the very end of the function. Very often we want to define that we want to open a file and then also that we want to close it, but of course we want to perform a whole bunch of operations in between those two things occurring. And you can see here if I save this and execute it that 1 prints out then 2. And the reason why is because of defer. Now let's create another function that's going to allow us to perform division in a safe way. It's going to receive a number 1 and number 2, and these are both going to be integers, and then it's going to return an integer. Here we're going to use defer again with function, and let's go print line and recover. Make sure you put capital P inside of there. And what recover is going to allow us to do is catch if an error would occur. So let's say we have solution here is equal to the number 1 divided by number 2, and we want to return the solution. Well, if they go and they send a 0 inside of here, what this is going to do is pop this up here to recover, and then recover is going to be able to handle that error if it should occur, because a division by 0, of course, is going to cause an error whenever the code is executed. Let's go up here and create that error. Format, print line, and then we'll go safe division and pass in a 3 and a 0 for a division by 0, and then we'll perform a normal division underneath that, and we'll divide by 2 or something. And you can see here it prints out integer divided by 0, but the program continues executing without completely crashing, and also goes and performs the other division right here. Another thing you're going to see is if I go in here and eliminate this print statement altogether and execute it, that's going to go and perform that division and not throw an error at all. So it's up to you exactly if you want to print the error out or you don't, but what recover allows us to do is to continue execution even if a fatal error should occur. Then finish this all off. Let's go and create another function to demonstrate what a call to panic would look like and how to handle a panic or an error that we can define with the recover function. So let's just call this demonstrate panic. Inside of here, defer, func again. We can decide if we want to print out the error or not. Here I'll just print it out just for the heck of it. Close that off right there. And if I ever hit an error that I know I want to send to recover, I just type in panic, and it will send it over there. And then up inside of here, I'll just call this function. So it's sort of a way of using exceptions and catching exceptions in other programming languages. And there you can see panic prints out. And of course, if I didn't put this print line here, nothing would print out. Now let's take a look at exactly how pointers work inside of Go. Let's come down here and create a function. Let's call this change xval. It's going to be passed an integer. It's going to go inside of this variable x. And here I just want to demonstrate that because I changed the value of a variable inside of a function, it's not going to have any effect up here in the main function. How I'll do that is I'll define x up inside of main, give it a value of 0, and then call change x val and pass x, but in this situation it's passing the value of x being 0, not x itself. And you're going to see that here. If I put print line and I say give me the value of x and execute that, it's going to print 0 out on the screen. Now pointers are going to allow us to come in here and actually be able to change the value. So let's get rid of this down here. Let's call this change xval now instead. Now down inside of here, if we want to signal that we are going to be sent a reference to the value and not the value itself, we're going to put a star right there. What this is going to allow us to do is actually to change the value at the memory address referenced by the pointer. And then by putting a star right here, this is going to allow us to store 2 in the memory address that x refers to. Has nothing to do with the value anymore. It actually deals with the actual variable. Now to pass this value, we're going to come up here, get rid of that. I'm going to call change x val now. If we want to pass the reference to x so the actual value can change, we put the ampersand followed by x. And then here, if we want to print this out, we're going to see that the value actually changed. So that is the power that we get with pointers. We're actually allowed to pass the actual memory address in and then assign a value to that memory address rather than passing by values, which is what happens by default. If we then want to prove this by printing out the actual memory address for x, we could get the memory address by putting ampersand and x just to prove a whole bunch of things. And there you can see it is the memory address. Likewise, we could print the memory address inside of change xval now as well. We could also come down here and let's change this to change y val now. Call this y pointer and then get y pointer and give this a value of 100 and then pop up here inside of main again. And we could generate a pointer with the new function like this and then call new int and then go change y val now. Pass in that pointer and then print this out on the screen. Y is equal to star y pointer. and execute it, and you can see 100 shows up there. And that's pretty much all it is when it comes to pointers. Way more complicated, or people make it way more complicated than it actually is. Just passing memory addresses and assigning values in a different way, nothing else. Now, structs are going to provide us with a way for us to define our own data types. So let's say that I want to define a rectangle data type. I would follow this with struct. And inside of here, I would define some things that a rectangle would have. So let's have maybe the left X position. Save that as a float. The top Y position, also a float. Height, also a float. And then width. And you guessed it, also a float. I'll then be able to go inside of a main and define a rectangle of my own making by calling rectangle. And then I can define all the different parts. I can go left X, colon, 0, top Y, colon, 50, height, colon, 10, and width, colon, 10, right like that. Or if I know the order that these are structured in, I could just come in here and go 0, 50, 10, and 10, and define them either way, it doesn't matter. One way is if you know it, one way is if you don't. Then we'll be able to access these values that I have stored inside of here. I could say something like rectangle, and put a quote inside there, of course, is, if I want to access the specific value, I just go rect1, width, for example, and then I could put wide, execute that. Rectangle is 10 whatever wide. And I could also define a method area for my rectangle struct as well. Just come down here and do that. And to define this, we'll go func, just like before. And then we're going to define the receiver, rectangle, right like this, so that it knows what to attach it to. And then the function name, which is going to be area. And then it's not going to receive any attributes, so there's nothing inside of there. And it's going to return a float, right like this. And then I could just go return rect width times rect height. And it's going to get the width and the height right out of here automatically because I defined this as a rectangle, that this area method is going to work with this rectangle struct. Save that, come in here, area of rectangle equals, and then rect1, and instead of putting that in there, I'll type in area. And if you execute it, it comes back with 100. So that's how you would define structs as well as assign methods to them. Another thing that's kind of neat is create interfaces and use a sort of polymorphism inside of Go. First, we're going to create a new struct. I'm going to call this shape. Struct works there. We could then come in and define a method that every other struct is going to have to implement if it's going to use this interface. So we'll go float 64. So we're saying that if you want to use our shape interface, well, I got to change this to interface. Sorry about that. You must implement the area method. I could then come in and create another rectangle struct. And then here I'll just keep it simple, have it have a height and a width. And then let's also, just to mix things up here a little bit, let's also create a rectangle or a circle. And there's a circle. And for a circle to figure out whatever the area of it is, all we need is the radius. And let's say it's a float as well. Well, I could then come in here and define functions. Here I'll just have our rectangle followed by area. And it's going to return a float. Close that off, bounce up in here, and go return r height times r width, and then do something similar for my circle. Down here, let's just change this to a C, call this a circle. And then here, let's say I want to use another guy here. Let's import another one of these math libraries. That's how we would do that. And then to calculate this, I'm going to go math.pi times math power, and then we would have whatever the radius is for our circle. And we'll square that to get the area for our circle. And then down inside of here, we'll define our area for our shape, which is going to be sort of a generic area. We'll tie it to the shape, just like we did with the other methods, and say that it returns a float and returns shape.area. And what's neat about this, see, these guys are all going to be tied together because of the interface. Now what we'll be able to do up inside of main is go and create a rectangle, which is of type rectangle, and we'll give it a height and width of 20 and 50. And then we'll also create a circle and give it a radius of 4. Oh, make sure you use curly brackets like that. We're then going to be able to call print line and say rectangle area is equal to, and go get area and pass in a rectangle. See, get area is this guy right here, which is tied to this shape interface we have right here. And we'll also be able to do the same thing for circle. So I'll go circle area, and then in this situation pass in a circle, and it's automatically going to call the right area functions. As you can see right there, made a little error whenever I first typed this in. I put a comma inside of there instead of a dot operator, so make sure you put dot operator. But you can see right there it automatically went and called the proper area function depending upon the type of data that we were working with. all because they were all tied to the shape interface. So kind of neat. Okay, now I'll go through a bunch of string functions, cover file I/O, accepting input from the user, and casting. Then we'll create a web server, and then I'll cover Go routines and channels, and we'll be all done. So let's create a string called sample string, and let's just give it the value of hello world, right like that. We could then check if another string is contained inside of it by going strings. We're going to have to come up here inside of this. Type in strings. We're actually going to be using a whole bunch of different imports, and if you want to import a whole bunch of things, very often it's easier just to go import, put this bracket right here, and we type a couple other different things. We're going to also cover sorting. We need OS package, cover log, IO, IUtil, and string conversion. So a whole bunch of different things. Close that off at the end. Alright, so if we want to see if it contains, we're going to pass in sample string, the guy we have here, and then if it contains the string LO inside of it, we would do that. And then I'm going to have this do a whole bunch of different functions here. Here, if we want to return the index for a match, if so should exist, we'll type in index there instead of contains. If we want to output the number of matches, we're going to say count, so OUNT. And let's say we want to check to see the number of L's that are contained inside of here. Let's actually get rid of all these different guys here for now. Paste them down here because I'm going to need them in a little bit. I could also come in here and replace certain values. I'm just using the print line here so you can see the output on the screen. So if I wanted to replace all the L's with X's, and I want to do that for the first three, that's how I would do it. And if I execute this, you can see that LO indeed is in hello world. That begins at index number 3. There are 3 total L's inside of here, and here I decided I want to replace all the L's with X's, and you can see the output that comes out with that. Could also come in here, get rid of that, and get rid of this strings right here. Always want to get rid of any imports that you're not using, otherwise you'll get an error. I could create a comma separated value string, give it the value of 1, 2, 3, 4, and 5, 6, format, print line. Now let's go and do another strings operator here. Let's say I want to split this guy. CSV string, every place that we have a comma, strings, up in there, and you can see it went now put that on the screen, which is going to return a nice list separating the values anywhere there is a comma. I could then also come in and do list of letters, create a string array, and let's put them out of order like that, and then say that we want sort up here, sort the strings, list of letters, and then output the letters. And there you can see them in order. And we could also join them in much the same way. So we'll say a list of nums, call strings, join string array, and we could say 3, 2, 1 like this, and say that we want to separate each one of those with a comma and a space, and then close that off, and then print out list of nums, and there you can see it printed them out. Now let's do some file I/O. So let's get rid of all that. And let's get rid of these guys right here and just type in OS, which is the package we're going to be using. If we want to create a file, we're going to go file, error is equal to os dot create, and we'll call this sample text is going to be the name of the file we're going to create. If we want to output any types of errors that might occur, just say error, if error is equal to nil. And then we could come up here and open a log to output this. And of course, we're going to need to come up here and import another package, which is going to be the log package. And there it is. We want to write a string to our new file that we just created. Go file, write string, and then whatever text we want to put inside of here. We'll say this is some random text. We then want to close our file. Just do that. We then could try to open our file, and we would do this even if we didn't create the file or whatever. Go IUtil, and then we'll put IUtil up here, OUtil, there it is, and read file, and provide the file name that we want to read from. Again, we're going to have an error catch here. If there was an error, it's going to print that out. We can convert this into a string. Go read string, right like this, and this is going to be the stream of data that we read from the file, this guy right here. Of course, put the equal sign inside of there, and then we could go format, print line, and read string, or read string, whatever. And this guy up here is IO / and then put double quotes there. Save that, execute it, and you're going to see that it opened, created that file, printed text over to it, and then read that text out again and displayed it on the screen. Whole bunch of different things. Now we'll just come in here and show you how to cast, and then we'll create a web server and a couple other things, and then we're done. So I promised you I'd teach you a lot of things. Let's go in here, delete all this stuff, go and create a whole bunch of random values. If you want to convert number types, So let's go print line. You want to convert an int into a float, just put float 64 and whatever your integer value is, and that's going to work. You want to convert from a float into an integer, you just put int and then whatever your float is, and that's how that would convert. If you want to convert a string into an int, you go new int like this, comma, underscore, equal to string conversion, and parse int random string. Then we're going to define 0 and 64-bit, and then we can print out new int on the screen. New int being an integer that used to be a string. And then we can do pretty much exactly the same thing to convert a string into a float. Let's just call this new float, and then random string 2. Here we'll get rid of the 0, just leave this be 64-bit because that's what it is, and then new float. And then just make sure this is lowercase c, this is lowercase c, and this is parse float. Jump over here, and you can see right there all those print out. Now I'll show you how easy it is to create an HTTP server. First, we're going to have to come up here. We'll have format inside of there, but we're also going to have to put net/HTTP, right like that. Now what you're going to do inside of main is go HTTP and handle func, right like this, and anytime they go to your server and go to the default directory, we're going to say that we want to call the handler function. Well, we'll have to create the handler function, no problem, func, and then handler. Inside of this, HTTP dot response writer, and the response writer is going to assemble the server's response and then write it to the client. We'll have r star HTTP request. And this is going to hold the client's request, and then if we want to output to the client screen whenever they go to our server, just go fmt, and here we'll go f print f like that, pass in w, and then whatever you want to go on the screen. And we can do more advanced things, but this tutorial is very long, so I'm just going to stick to this. And there we go. Now let's say we wanted to do this for another directory. So inside of main, let's go create another one, handle function. Let's say they go to something called earth, a directory called earth inside of our server. And let's say we want handler 2 to be called in that situation. No problem, just duplicate this, paste that in there, change this to handler 2. And then in this situation we'll have it be hello world, and then here it'll be hello earth. I don't know, just something to do something. And then the final thing we need to do inside of main is tell it which port to listen to for our server. And we'll just type in listen and serve like this, colon, let's say we want it to be 8080, pass in nil, jump over here, execute it, you're going to see that it pauses. Jump to localhost, you're going to see hello world shows up right there. And if I come in here instead and put earth like that, now it's going to say hello earth. So that's how hard it is to create a web server using Go. Alright, now let's talk about some Go routines. I put time inside of here because I'm going to be showing you how to pause some events, and we're going to create a Go routine, which is basically going to allow us to run multiple different functions in parallel. So let's go inside of here. You can also create functions up here. You can create functions anywhere really. Let's create one called count, and it's going to receive an integer that's going to have the name of ID. This, go inside of here. Let's go and create a for loop inside of here, equal to 0 while I is less than 10, and then increment I. And then inside of here we can just print out to the screen. It's like a thread ID, and then something like this, and I incrementing. And then we're also going to create a pause of 1 second inside of here. To do that, we'll use time, and this is just so this function will temporarily sleep so that it has time for all the other functions to execute. So a second times 1000, that's going to give me a 1 second pause for this guy. And now down inside of main, I'm going to create another for loop equal to 0. It's going to create 10 of these guys, 10 versions of count. And then the Go routine is executed by going Go and whatever you want to have execute. So I'm going to say count I. It's going to create 10 of them, just like I said before. And then what we need to do inside of main is create another sleep so that this pauses long enough for all the Go routines to execute. So a millisecond times, I don't know, let's try like 11,000. That's all we need to do. Oh, to shut down the server over here, just go Control C. There, it's shut down. And execute, you can see everything is executing. Here are the different versions of count, 0, 1, 2, 3, and here it's printing out all those different pieces. So that is what a Go routine looks like, and you can see right there it finished. Like I said, if you guys are interested, I'll create a whole bunch more Go tutorials doing really cool things. I plan on doing so otherwise. And then that brings us to channels, which are going to allow us to pass data between Go routines. And here I'm going to make some pizzas. So let's just come in here and let's create a function, and let's call the first one make dough, and it's going to receive a channel. And this is how that works, how you define that you're receiving a channel. And I do a couple things here ahead of time. I'm going to need this, and I'm also going to need to convert a string, create some variables outside of here. Variable pizza number, because I'm going to create a bunch of different pizzas. Each of them is going to have its own number. And pizza name is going to be the pizza name whenever it prints out. You'll see here in a second. So whenever it says, hey, I want you to make me a new pizza, well, the first thing we're going to do is we're going to increment the number of pizzas that we're creating. The first one's going to be number 1. And then I'm going to go pizza name is equal to pizza number plus string conversion. And what I'm going to do here is convert this int into a string. So that's pizza number, like that. And it probably makes sense to go down in main here and do a little bit before we start jumping into the different Go routines. So here we are inside of main. And here we're going to create a channel that's going to be able to hold a string. So I'm going to call it string chan. Like I said, this is just going to allow us to pass string values back and forth between all of our Go routines. Chan. And this is going to be a string that's going to be passed between the Go routines. If it wasn't, we would have this be an int for integer or whatever. Everything else will be the same. And then we're going to cycle through and make 3 pizzas. So we'll go for I colon is equal to 0, I less than 3. We're going to keep creating pizzas until we have 3 pizzas made. But we're going to have to make the pizzas in order. Dough, and then sauce, and then toppings. So we're going to go for our Go routine, just like we did before, just a second ago. And we're going to pass in our string, this guy right here, and those strings are then going to be passed between all the different ones. So there we go, there's that guy. Now we'll jump back up here, and let's say we want to print out onto the screen that we are currently have made our dough, and we need to get sauce for our pizza dough. So make dough and send for sauce. There's that. Now if we want to send our pizza name onto the channel for the next Go routine, we're going to say this string chan, there's that guy, same guy that was passed inside of here, and to pass it on to the next Go routine like this, and pizza name is what we want to pass. Then we're going to also sleep for a second so that the Go routines have time to come in here and execute. Let's say 10. That works. And then we'll create a couple more of these. Let's go and create another one that's going to allow us to make our sauce. So let's just call this one add sauce. It's going to be passed in that channel, that string. And if we want to receive the value that was passed into this channel, let's go and create pizza and give it a value for string chan that was passed in there. There we are. We don't need to do this because this was passed in. No problem. And here we could say add sauce and send, and then pizza, which is going to be pizza followed by whatever the number version it is, and 4 toppings. Again, I put those semicolons in there whether they're needed or not. Then if we want to pass it on to the next Go routine, this is going to stay exactly the same, and this guy's also going to sleep. And I'm going to create a final function that is going to add my toppings. There's that. Again, string chan is the name passed, and string, and then add toppings is going to store pizza followed by the number that was passed inside of this. We get that value that was passed with putting that little bracket there with a dash after it, and string chan, which was passed into it. And then we could go format, print line, add toppings to, if we wanted to print out the pizza name, there we are. And then we could say something like and ship, and then put the little timer inside of here again to make sure everybody else has time to get finished. And then down here we're going to go make dough. Well, actually after this we're going to have this sleep also, so like this, and then change this to something like 5,000 so that we know it has enough time to get our pizzas made. And then here we will get this guy, create our different Go routines, and they are going to be add sauce like that, and then the final one is going to be add toppings. If I did all that right, you're going to see make dough, send for sauce, add sauce, send pizza 1. This is what we've been passing back and forth between the different Go routines with the channels. And you can see it's adding all those, and it's doing it one by one until it's finished. So there you go, guys. Just covered a heck of a lot about Go and how to program with Go. Please leave your questions and comments below. Otherwise, till next time.